In this section, we're going to be studying interest. There are two different types of interest that we'll be looking at. We'll be talking about simple interest and we'll be talking about compound interest. So what exactly is interest? Well, interest is the money that an investor receives from a borrower for being able to use the investor's money. In other words, if you're going to borrow money, generally no one's going to let you borrow money just for free, and so you have to pay an amount in order to be able to borrow the money. So for example, if you borrow $1,000, you don't just pay back the $1,000, you pay back the $1,000 plus an additional amount, and that additional amount is called interest. Likewise, if you invest money, people don't generally invest money for free. So if you invest money, then you receive money back for allowing someone else to use your money. And so that amount that you receive for your investment is called interest. So again, interest is the money that an investor receives from a borrower for being able to use the investor's money. Now, the principal is the amount of money that's invested or borrowed. So as I said before, if you borrow $1,000, then $1,000 is the principal. If you invest $1,000, then that $1,000 investment is the principal. The interest rate is the percentage of the principal that the lender receives or the borrower pays. So that's going to be a percent, and the investor receives that percent of the principal for the investment. Now, as I mentioned, there are two different ways that that interest is typically calculated. It's either simple interest or compound interest. So we're going to begin by looking at simple interest, and then later on we'll talk about compound interest. So, simple interest. Well, we have a formula for that, and that is I equals P times R times T, where I stands for the interest, P stands for the principal, R is the annual interest rate, generally going to be written as decimal form, and T is the time in years. So I equals PRT, interest equals principal times rate times time. And again, that rate is typically going to be an annual interest rate, and T is going to be the time, and that's going to be in years. So the interest rate, so like for example, if you get a 8% interest rate, then that means 8% per year. And so again, then T has to be in years. Those units have to match. So let's take a look at example 1. Suppose $5,000 is invested for 3 years in a certificate of deposit, generally referred to as a CD, that pays simple interest at an annual interest rate of 4%. Part A, how much interest will be earned? Part B, what will be the value of the CD? Meaning after the 3 years, how much money is your CD worth? So, in order to determine the interest that will be earned, we need to identify the principal, the rate, and the time. So we are investing $5,000, so that is our principal. P equals $5,000. We are investing that for 3 years, so that is the time. The time is 3 years. And we're getting simple interest at an annual rate of 4%, so that is R. R equals 4%, and again, typically we're going to write that in decimal form, so that would be 0.04. So the interest that we're going to earn, again, we're using simple interest, will be the principal times the rate times the time. So that is going to be $5,000 times 4%, so that's times 0.04 times the 3 years. So whatever 5,000 times 0.04 times 3 is, that is going to be our interest. So if I bring in my calculator, 5,000 times 0.04 times 3, that is 600. So our interest is going to be $600. Now with simple interest, the way it works is the interest is only paid at the end of the time period. So after 3 years, when the 3 years are up, we will receive $600 in interest. We don't receive any interest until the end. So what would be the value of the CD at that point? Well, the value of the CD is going to be our original principal plus the interest that we've earned. So in this case, our CD is worth the $5,000 that we invested in the first place, plus now the $600 in interest. And so 5,000 plus 600 is $5,600. So after the 3 years are up, the CD is worth $5,600 because we are, again, we have our original $5,000 plus we earned that $600 in interest. Let's take a look at another example. Look at example 2. So example 1, we were investing, but in example 2, we're borrowing. So suppose Mary borrows $1,200 for 9 months at an annual interest rate of 8.2%. How much interest will Mary have to pay? Again, we're talking about simple interest in this particular problem. So pretty similar to what we did previously, with one catch. In this case, if we try to identify our principal, well, the principal is the amount Mary borrowed, so that's going to be $1,200. Now, she's borrowing that for 9 months, so the time is 9 months. And the annual interest rate, R, is 8.2%. Again, that's annual, so that's per year. And we will write that in decimal form, so 0.082. Now, the catch on this problem is that the time in this case is months. It's 9 months. But our interest rate is an annual interest rate, so it's 8.2% per year. Well, we can't mix months with years. We have to have the same time unit on both of those. So again, if you'll remember back up here, in our simple interest formula, T is the time in years, not the time in months. So we need to convert our 9 months to years. Well, since there's 12 months in a year, then that would be 9 divided by 12 years. And if we reduce that, 9 divided by 12 would be 3/4 of a year. So our time isn't going to be 9 months, really. We're going to think of that as 3/4 of a year. So now we can calculate Mary's interest. So it's going to be our principal, which is $1,200, times her rate, which is 0.082, times her time, which is 3/4 of a year. So if I bring my calculator back in, 1,200 times 0.082 times 3/4 of a year, and so that is $73.80. So how much interest will Mary have to pay? She'll have to pay $73.80 in interest for borrowing that $1,200 for the 9 months. Now, it didn't ask in this problem, but we could have asked a problem similar to Part B up here. How much altogether does Mary have to pay back for her loan? Well, she would have to pay back the $1,200 that she borrowed plus the interest that was earned on that. So she would have to pay back $1,273.80 if I add those together. That's how much she's paying back in the end. Let's take a look at another concept on this video. The future value is the amount of money that an investment or a loan will be worth at some time in the future. The present value is the principal originally invested or borrowed. So if we want to compute the future value using simple interest, we have a formula. A equals P times the quantity, 1 plus R times T in quantity, where A is the future value, P is the principal or the present value, R is the annual interest rate, and T is the time in years. So take a look at example 3. If you deposit $2,000 in an account paying 2.5% annual interest for 5 years, compute the future value of this account. Now this is kind of similar. In fact, this is exactly similar to what we did in Part B of Example 1, except we now have a formula that we're going to use to compute that directly. So we can compute our future value directly instead of having to do it in 2 steps. So we're looking for A. What is the future value if we have a principal? So P is going to equal $2,000. That's our original investment. Our rate is 2.5%, or as a decimal, 0.025. And our time is 5 years. Notice this time our time's in years, so we're all good. So our future value, A, is going to equal our principal, which is $2,000, times, using my formula here, 1 plus my interest rate, which is 0.025, times time, which is 5, and that's it. So if I bring in my calculator, 2,000 times 1 plus 0.025 times 5, close parentheses, that is $2,250. Now that is dollars because it was $2,000 that we have right here. So if I deposit $2,000 in an account that pays 2.5% annual interest, and if I leave it there for 5 years, at the end of the 5 years, that will be worth $2,250. So my $2,000 will have grown to be $2,250 after the 5 years are up. Let's take a look at example 4. Suppose a savings bond pays 2.5% simple interest. If the value of the bond will be $1,000 when it matures in 10 years, what should an investor pay for the bond today? Now this problem here is backwards from example 3. So the reason it's backwards is the value of this bond is supposed to be $1,000 10 years from now. So that's the future value, that is $1,000. And so it's going to be $1,000 in 10 years. So if it's going to be $1,000 10 years from now, what's it worth right now? What should we pay for this bond? What should we pay for this investment in order for it to be worth $1,000 10 years from now? Well, we can do this with the same formula. The difference is we want A to equal $1,000 in the future. And in the future, that is 10 years in the future. And our interest rate is 2.5% per year, which again would be 0.025. So in this scenario, if I used my formula, future value equals principal times 1 plus R times T, then I know A, I know the R, I know the T. What I don't know is P, and so I have to figure that out. So 1,000 is going to equal what times 1 plus 0.025 times 10. So I have 1,000 equals P times something here. Let's figure out what that is. So if I take on my calculator 1 plus 0.025 times 10, that is 1.25. So what I really have here is 1,000 equals the principal times 1.25. So to figure out what this principal needs to be, I'm going to divide both sides by 1.25. So my principal is going to equal whatever 1,000 divided by 1.25 is. So if I bring my calculator back in, 1,000 divided by 1.25, that is 800. So this equals 800, and that is dollars. Again, because the 1,000 was dollars in here. So what should the investor pay for the bond today? Well, if the investor pays $800 today, then 10 years from now, under this condition, that $800 would be worth $1,000. So again, what we have found here is the present value for something that should be worth $1,000 10 years in the future. Incidentally, we could check that. So if I were to take and substitute 800 for P and multiply that by the quantity 1 plus 0.025 times 10, so again, that is my principal, and that is the rate as a decimal times the time, then that is $1,000. So my $800 that I pay for now will be worth $1,000 10 years in the future. So let's continue this lesson on a new video.